rod bearings. I will tackle the rod bearings on the 2003 R53, that's the supercharged model. What was the problem? Draining the oil and glitter and sparkle as it came pouring out, and slowly getting worse. I'm not getting any other symptoms. Engine runs fine. Maybe a bit of a rattle on startup. Could it be the rod bearings? 23 years old, plus 200,000 Ks. Okay, so it's possible these rod bearings are getting a bit tired. Valve cover off and check the cam. No sign of a problem. There's several other things it could be, but what I want to try is the rod bearings. Actually not too big a job to do. Of course, if it's actually spun a bearing and wrecked the crankshaft, this, at the cost of a second-hand motor, I'm not going to be fully reconditioning this. The parts, reasonably cheap. Parts cost $100, perhaps, US dollars. Probably the most expensive part of the rod bolts, 48 US dollars for genuine mini rod bolts. The bearings, I got those from RockAuto, and what were those, about 25 US or about 50 New Zealand dollars. Shouldn't be more than a few $100s, even with good parts. Gasket for the Sump, Plastigage. Look at those, they're tiny, aren't they? EngineTech bearings, new ones. I've just bought standard size. Now I'm not planning on machining it. If it needs machining, I've got bigger problems. I'm hoping that the rod bearings, that they have not spun and they have not damaged the crankshaft. Tool, so these are torque to yield bolts, right? So you're torquing up to a certain level and then doing degrees rotation. And being torque to yield, you need new bolts, and I've just bought standard mini ones. I got a O-ring for the oil pickup. Assume the position, put it into front end service mode. You get pretty quick at it after half a dozen times. Bumper off, crash bar off. Now I don't want to drain the cooling system. I don't want to depressurize the air conditioning. I've unbolted that just enough so that I can pull this out. What I need to do is gain access to the air conditioning compressor. That's in the way. A couple of bolts holding it in. 1, 2, and there's this long one holding it to the oil pan, plus that electrical connector. To remove the air conditioner pump, you need to remove the auxiliary belt, which is a bit of a pain. It does require special tools. Special tool to take the tension off, then you can pin the tensioner back. That gives you enough slack to get the belt off. I've also taken out these crash bars, the power steering fan, and the lower engine mount. With those out of the way, it's quite easy to access the bolts holding the sump in place. The sump has 13 10mm bolts, and there are 3 big bolts into the transmission housing. There's no big chunks of metal in the pan. That's a good sign. I'll take this oil pickup tube off to get a bit more clearance. Now I've got a replacement O-ring for this. And there's that O-ring I will be replacing. Of course, if you've got big chunks of piston lying around down here, perhaps not worthwhile replacing your rod bearings. So you could wait till you've got to this point before you actually order any parts. Be the smart thing to do. So now I've got access, I can remove those caps. So next we're checking the connecting rod end play. That is how much is meant to be play, side to side play. It just needs to be within tolerance. I've already done this off camera, so you go in for the biggest feeler gauge you can fit between the side of the rod bearing, all in place before you take it apart. This is the biggest one I can get in there, 0.18mm or 7 thousandths of an inch. And all of mine were the same as far as I can tell. Hopefully that's a good thing. And you can use a 15mm spanner on the crankshaft bolt to turn the engine over to get these good access to each of the bolts. 10mm bolts on the rod bearings. I don't like the feel of that. I'm going to get a better, tighter socket. Now I'm actually using a big breaker bar and a 10mm. I recommend you whichever 10mm gives the tightest fit on that socket, because these are pretty tight. Oh, I don't like the feeling of that. I've got to reuse these for checking clearance. We'll give a socket a try, a 6-point socket, optimize the surface area, and it's also a 1/2 inch drive. I had 6 points that were 1/4 inch drive. I have 12 points that are 3/8, but I did not have any 6 points in a size big enough to break those free. So we'll give this one a try. Interesting, I've also, so I've done this flat-sided, you can put a spanner on here, which I suppose would be handy. And you know what? It is a tighter fit on these bolts. I just want to hear that little pop, and you are free. Crack, that's what I wanted to hear. Yep, and this one. Yes. So if you're doing this job, I do recommend you buy a brand new Milwaukee 1/2 inch 6-point 10mm socket. I thought my ones were fine. I was wrong. First rod cap out. There's the cap, and there is the bearing. I'm not feeling any ridges. We'll pop the one out from the other side, the other half. Okay. Yep, this is what we were looking for. You can see that the finished surface has worn through. Good. Yeah, we might be on the right track here. I can't feel any roughness. So that's what 200,000 kilometers of wear looks like. So I've ordered them. Cylinder 1 to cylinder 4, and these are the upper bearings, are showing more wear. That one's cutting through to the copper. Is that enough to explain the sparkles in my oil? I don't know, perhaps not. There might be something else. That one's breaking through to the copper as well. Yeah, so is that one. So I'm glad I replaced these. But yeah, certainly no sign that the bearing has spun. You know, when they talk about the spun a bearing, the bearing moving around this surface, which is should not be a wearing surface. So this is the bit we can easily replace. If the crank has wear in it, that's a problem. How does the crank look? It certainly looks nice and smooth. I can't feel any ridges. Feels very smooth. Good. Okay, so far so good. You can see lines on it. Very smooth. Marked, but not worn. So first, you go over it with some brake cleaner. Try and get rid of any build-up or accumulation on that surface. And to extend the life of this engine, not make it new again, extend the life, I'm going to take some wet and dry, or emery cloth if you like. Now some call it polishing. On the crank, I want to prepare it for the new bearing. So the question of what grit to use. I have not tried this 100 times. This is my first time. What grit to use? A lot of people are going for a polish using 1500 or 2000 grit. Really fine. Going for a mirror finish. But then a lot of people in the comments, people working in machine shops, leaving the comment, hey, in the machine shop we'll use 400 and step down to an old piece of 400, and that is all. Of course, they're starting with the machine finish. So all I'm wanting to do is knock down any fine ridges. I can't even feel them on the crank. It feels smooth to me. So any fine ridges on there so that they don't cut into the new bearing. I want a nice flat surface. And the debate of how fine you go, fine, a polish. Sounds good, right? You want, it should be nice and smooth, low friction. But of course, it's not actually the metal that is the contact. It is the oil that is the contact. So you want a finish that holds oil. That is why I'm going to start with 400, go to 600, and then stop. Proper way of doing this is you're taking your engine apart, getting, you're overhauling it, including getting all of those, getting your crank machined and going to a oversized bearing. I'm not reconditioning this engine. This is just extending the life. So DIY, can I extend the life of it? Because the alternative for me is not taking and stripping this engine down and reconditioning it. The alternative for me is going out and buying a second-hand motor. Problem with the second-hand engine, is it any better than your old one? I'll start with what I know, the engine I have. If that crank was looking perfectly smooth, no lines, I would just leave it alone, to be honest. The risk you run is when you're sanding with wet and dry, you're leaving behind some sand from the sandpaper. Any of that gets into the engine. Sandpaper and engines don't mix. So if it was a perfectly good surface, I'd leave it alone. Mine's got some very fine ridges on there. I just want to knock off those fine ridges. I can't feel the ridges. I asked my daughter to check with her younger fingers. She can just feel it with her fingernail. I've cut a strip of P400 about the width of the bearing, and we're going to use a slightly wide shoelace. We'll use some CRC to lubricate that. Do not use this stuff dry. Some CRC on the surface. Wrap that shoelace around there. That surface to have had pressure applied to it. That looks like. Give some brake clean on there to clean it off. And what I'm looking for here is absolutely no sign of any lines or ridges or bumps. This is the power step. First step, it should knock all that down. All the subsequent steps are just the polish. That's how it looks after the 400, and just a light clean. I'm just cleaning to inspect. If I get rid of any sign. And with the 400 done, we'll go to the 600. Okay, do 2 minutes on that one. Okay, that's about 2 minutes. Let's have a look. I quite like that finish. That'll do. A little bit of sandpaper getting into this hole. We'll be wanting to clean it out 100%. So, new bearings. I got some EngineTech bearings, standard size from RockAuto. EngineTech, where's this? It says made in Israel. Copper, lead, aluminium. These aren't racing bearings or anything like that. So you can see two different colors. There's an upper and a lower, and the part number finishes in an L. So that's the lower bearing. Goes on so. And this one, it's a slightly different color. Letter U on the end of the part number, that is the upper bearing. Notice these are not polished either. They need to hold oil because it is the oil that is doing all the work. Now, dry fitting first to check clearance. Given this conrod cap a clean up, put the new bearing in. Now notice it has this notch, so that means it'll only go, it only has notches on one side of the cap. Positions it horizontally, so I'll just slide that notch in there and press it home. The lighter colored one with the U on it for upper, what I find more successful is dropping this onto the crank and pulling the conrod down over the top. Doing it that way also means if I do slip, I'm only going to scratch the back of this bearing, not the crank. Okay, that bearing's in. Again, these are cracked rods for a better fit. They're not cut like a machine, they're cracked, and that crack lines up with the other side of the one that it's broken from. That is why these must go back onto the rod which they came off. You cannot mix these between. There's no way they have cracked the same way. So you could put it on the wrong way, you could put it that way or that way. It's only going to go one of those ways. Notice these have a number on one side and a letter B on the other. So I've made note of that, and we'll put that back on the same way. After I wriggle this into place on the top, on the conrod itself. It seems to be the easiest way. Put the bearing on top of the crank and pull the con rod down onto the bearing. Plastigage. So we're doing a dry fit, making sure the clearances are within spec. And, you know, the proper way is with a whole set of gauges and measuring both sides with specialized instruments, calibrator, blah, blah, blah. I'm not doing that. I'm taking the, I don't have $1,000 worth of tools routes. And actually that's what I'm surprised even the Hengst manual says compare with the width with cross Plastigage. Here we go. They say about, you're aiming for about 0.05 millimeters. What's that, 2,000ths of an inch? 0.023 to 0.067 millimeters new, and a 0.07 as a upper limit. And there it is in inches. Lots of guides on the internet on how to use Plastigage. It's a little thin piece of wax hiding in this paper. You put that little piece of wax in there and it gets crushed. When it gets crushed, it spreads out thin, and you check how far it spreads out against this. Using the old bolts to do this, right? Because these are torqued heeled bolts. We do not want to use the brand new bolts for the dry fit. Otherwise we'd have to throw them away. Even a nice little picture here. Across the bearing face and then measure it against the scale printed on here. So I'll cut a piece about that long. There it is, right? Tiny little piece of wax, that bit of wax across here. And we're going to bolt that in place and see how much that gets crushed. Even though you're assembling it dry, it should be clean, okay? I do not want to press a piece of sand in there. Also, remember, get the cap around the wrong way. In my car, I'm putting the B on the cap to clutch. And I'll put that on nice and carefully, and it should go on nice and snug. And then talking to 15 foot-pounds plus 90 degrees. So for my torque wrench, that is 180 inch-pounds. It's not a lot, right? Plus 90 degrees. Got my dial gauge here. And I will lock it into this bolt hole. Here we go. 90. I will then remove it and we'll check that Plastigage. So it is that line here we are measuring. That is our Plastigage. And here is our scale. How wide is it? A little bit wider than that. Okay, so 0.023 to 0.069, we're definitely at the lower end of that scale. We're well within spec. I mean, it's probably less than 0.03 millimeters. That's good. And on the side, here are the inches. If you're into that sort of thing. Yeah, so we're down just above that 0.01. So we're actually on the pretty close to the new spec. The Plastigage was indicating they're all within the range of 0.03 to 0.04. Next, clean the wax off, clean all those surfaces up again, put in some assembly lube, and it's ready to go back together. So we're nearly halfway on one cylinder. Assembly lube, I'm going to mix some moly grease with some motor oil. Mix those about 50-50. Go to your store, buy some assembly lube, you're all done. I just get sick of all those little bottles cluttering up my workbench. Hello. I was reading a report from Mahl on reasons for bearing failure, and the number one cause for bearing failure was dirt getting in here, dirt getting on top or underneath. With the Plastigage, you see how much that tiny little piece of wax gets squashed out. Okay, there's a very small gap in between there. Imagine you get a little bit of sand or dirt on here and assemble it. That's just going to get crushed, right? It's not going to wear it out quicker. It's going to wear it out the very first time you turn that con rod over. Yeah, what's more important than what type of assembly lube you use is making sure there's no dirt in your assembly lube. Don't get out some old grease that has been open to the air. Imagine if you'd never know if there was dirt in that grease. So make sure you're starting with a known clean assembly lube or grease. And if you're using grease, the manual recommends a Mahle grease. This is the one I've used. Okay, putting this back on. Again, I've got the B towards the flywheel and the long serial number towards the auxiliary belt. So I put assembly lube not just on the bearing faces, but also on the sides, on the thrust face as well. Okay, and with those brand new rod bolts, I've bought standard genuine mini ones. You can get the ARP ones as well. They're not that much more. B towards the back of the engine. And I'll mark those with a pen so I know I've torqued them. All 4 bearings are now done, all back together, torqued up. Reach the bolts with the last 90 degrees. On the oil pickup tube, before that goes back in, I'll put a new O-ring on there. I'm just fishing around in here with the hook. Just check there's no big chunks of anything in here. Look what I found. Time to put the oil pan back on. Have a nice big rubber gasket. You want to clean up those surfaces, of course. I'm a little surprised. I actually replaced this not that long ago, 3 years ago, I think. So yeah, surprised to see it breaking up in a couple of places actually. And I'll replace that with the VICTOR REINZ. Wasn't leaking a lot, still doing the job. A few little tricks with getting the oil pan on. Firstly, that gasket has some lugs which locate it on the bottom of the motor. So you're putting the gasket on the bottom of the motor and then bringing the pan up to the gasket. Okay, it's got those little lugs there to hold it in place. A little bit fiddly. But 13 of these 10mm bolts, 11 short ones that go around the edge, 2 long ones. So that's all straightforward. Of course, you've also got these 3 big bolts. 1, 2, there's another one around the corner here. So they're pulling the pan that way, while these are pulling the pan that way. So which would you do up first? The Hengst manual says to torque these up first, and then those. I don't see any way where you're not ending up with it sort of trying to push and pull on that gasket. One other option to help protect that gasket would be to put a little bit of engine oil on that gasket just to slide about a bit. It is getting pushed and pulled. Either way you do it, make sure you get all of your bolts in, gasket located right before you put any torque on it. 23 foot-pounds, 31 newton meters, and the bigger ones, the 15mm that go across from the oil pan to the clutch housing, 63 foot-pounds, 85 newton meters. And here's the torque sequence Hengst manual gives. It's gone around several times in sequence to pinch those down. And this might be the final one at 23 foot-pounds. Let's see. You're generally going from the middle to the outside. We'll move on to 63 pound-feet for the new ones. Okay, all done. You go around and double check you haven't missed any with, what is it, 16 bolts. It'd be easy to miss one. Next is the air conditioning pump. 3 13mm bolts. These bolts get torqued up to 18 foot-pounds. Then I'll put that lower engine mount back in. You can rock the engine right with your hand to get it in place. And the fan's an easy one. 2 bolts plus 1 electrical connector. Next is putting that fan belt, putting the auxiliary belt back on. And for the Cooper S, that's the layout. Levering the tensioner pulley up so I can pull that pin out. There's a special tool for this. I don't have the special tool, but I've got this bar that kind of does the job. Now, because I don't have the special tool, what I do is back this bolt out a little bit. That's the top tensioner bolt, out enough to support a flat metal bar. And I've cut a bit of a notch in this, and it's supported on that bolt. You can see it in lever on that point right there. Time to put the front end back on. Heaps of videos on that. All back together now. For the first run, I'll run some cheap oil through it for startup. Let it run for a while. I'll then dump that oil and get rid of any contaminants I've introduced. I'll drain that out, and then I'll put a brand new oil filter and the right oil. Thanks, Dr. Ping, for the oil. I'll scream if I need you to turn it off. And then start it up. Sounds good. We'll let that run for a while. On your first startup, main thing you're looking for is oil pressure. This is the oil pressure warning light. That should go out just after startup. If that light stays on, you've got a problem. Shut it off quick. Another option for the first startup is you can pull the spark plugs, pull a fuse, and crank it for a while to get some oil through the system. I did not do that. With assembly lube put in at most 2 days beforehand, I wasn't too worried about the bearings being dry. Yeah, that is much better. I didn't realize the sound was the rod bearings that I was hearing, so I didn't record it. The sound I was getting, it wasn't a rod knock. On startup, there would be a flutter, like a... It would just last a few seconds until oil pressure built up. There's the old one out. We'll put a new one in. There's probably entire YouTube videos on what sort of oil you should run afterwards. Recommended is 5W30. I'm putting on a 5W40. I think the Mini is 4.5 litre capacity. Should you attempt this, it's not too hard a job on the Mini. There's a lot of cars I know have subframes and cross members and things in the way. You know, some cars you literally have to pull the motor out in order to drop the oil pan on. All right, I'll leave some links in the description below to the parts I've used. Also any mention of any special tools. So for the Mini, quite straightforward. Probably the most difficult thing, like all jobs on the Mini, is getting that auxiliary belt off so you can get the air conditioner out of the way. And there is a special tool for that. I'm making do with a flat bar. Life would be much easier with the special tool. Who would have thought 10mm socket would be a special tool, but certainly in this case it was. So that Milwaukee 6-point socket not only broke the other bolts free, it was also able to break free the socket that the 12-point had stripped. So quite impressed with that. I would recommend it. A couple of dollars, a fresh new socket for this job. Now, of course, if you've got the motor out of the vehicle upside down on a stand, you'd be able to get exactly the right angle. Working underneath has its disadvantages. It also has its advantages. I suspect you're less likely to introduce dirt and contaminants. You just need to be very careful, not just with cleaning parts, but also when you're installing. You don't want to put anything on the ground. You know, it's something you do subconsciously. Get a bit of assembly lube out and then put the container down on the floor where it picks up. It's a sand. Be careful with what you put down. Be very careful with the grease. I'd like to hear your comments. What sort of finish should you go for on the crankshaft, assembly lube, you know, all those things. There's a lot of those points. It didn't seem like there was any clear resolution on the web, on the forum, so I'd appreciate your input. I'm sure everyone else would. Thank you.